safe programming, programming of safety issues of programming, or security issues of programming. It's more related with the safety, right? Your program doesn't behave the way that you think, the way that you design, because that's not something you can handle it. There's a Python implementation. $257. Okay, so I already explained that. Two different objects. Yes, there are two different objects, but is it what we are comparing right now, like Java or C? No, it's not, right? In Python, we do not really differentiate the content from objects. For another nonsense here, think about it. Try this. A equals 257, semicolon, B equals 257. Returns true. So the way that I explained right now works, right? But if you issue these two together in one statement, what happens? In Java, in Python implementation, if it is one line, then create one, and then A and B together, like this. That is what you can see here. If you have two variables in separate lines, then it returns false. If you have this in one line, also this is two different statements, right? Therefore, we have semicolon in between, but it returns true. That is exactly the way that it is originally rely on array.
Professor, this is only for the interactive mode, or also if you write this in your Python code?
I think Python code. I'm not sure.
If
Would you play? Would you? Can you
because
try?
I'm checking for the interactive mode.
Interactive mode, yes.
But if you just
No, I
organize
didn't try.
Python
Let's try. Try to
create
create a file and right.
say, okay.
See what it. You can do print. You do that and print a. Oh, we can
But
try.
It should be the same.
Okay.
It's just the column that they.
That's right. Let me. That's a good question. So question here is. I have it here. Let me explain first, because so Python Python 3.4, Python, and when I do A equals 255, B equals 255, and A is B, then it returns true. But if I say A equals 257 and B equals 257, A is B, then it returns false. But if I say A equals 257 semicolon, B equals 257, which is two statements in one line, the same line, and then A is B, then that's true, right? So Pamela asked questions. What if we have to bring another what if we have a file, save it, that, I'm going to change the directory of this class. Python. Okay. So that I'm going to copy work.py to
You say true.
where's the file? Pi nonsense, not pi. So over here, I'm going to remove that. And then simply A equals 255, B equals 255, C equals 257, D equals 257, another E equals no, and then print A is B, print C is D, print
C is the.
E is 257. I'm not sure it works in this way. I'm
Professor,
not sure.
print C is the, not C E I D.
Oh.
It's just a.
Python and Py. Invalid syntax. How did you test?
I test this, and even if you use do A equal 257, B equal 257, print A is B,
Yeah,
it's always
you can-
true.
Yeah. You do that way. You can print
Yeah, because
after this. Together.
it's always true.
Right.
So recognize that the same object.
Why? Yeah, program is a little, I mean.
Maybe the interactive mode
Yeah,
recognizes.
interactive mode only. Fine. So in real real implementation in a file, it's not really the matter. I think that is an interactive mode only. Yeah. Yeah, interpreter issue. Interpreter issue. The way it interprets in the interactive mode, it interprets that way. We can test it using a compile mode. Okay. It works like that. Compile, function compile in Python takes parameters, source, file name, mode, and more. And it returns code objects. So compile, this one is the API of that compile. Compile the source into a code object that can be executed by exec or eval function. The file name will be used for runtime error messages. The mode, your mode must be exec, so that is execute to compile a module. And then don't inherit. This is a kind of API when you use compile function. So we try that compile. It's very slow. This is so in the user interactive mode, how can you get the memory information so that A equals to 57 and B equals to 57 so I want to try that, this code. Name, put this code into that. That's a source. Right now, there's no file, so empty, and mode is exec. So 3 parameters in this function compile, and assign the outcome of a compilation to whatever the variable here. We can say code object A, and then if you type code object A dot code constant, then it gives us the constant value. For example, 257, there is a constant value assigned because A equals to 57 in the code, it means we assign constant value. So this command here gives you constant value. Same thing here, B equals to 57, the same code, but if you do this, then again 257. None.
None.
Together, A equals and B equals together, then which means we have one constant, one one array, like 257, that A and B together assigned. We have a one constant created. There we have two variables, A and B. Same thing here. Um, Once you have a compiled, as we looked at here, dot co constant, it gives you a constant value. Dot co underscore code, it gives you co. Dot co variable name, var name, it gives you that. So try that in the code. Let's try it together. Okay. Here, let's say SRC equals A equals 257. There's a source, and we can do let's say code A equals compile, and then SRC source equals SRC, and file name equals nothing, and mode, you have to say execute here, mode. And after this, if you want to see code underscore A dot co constant, it gives you that. Similarly, co variable names, there's no variable names, which means A is a variable, but it is not saved in the code. 257 value is created, and it is pointed by A and by C to the same location. That's what it means. CO code, compile the code, it returns that byte code. That's a compiler. We do not have to know about this code saved there. When you have A equals 257, that's a code, source code. In hex, it is written in this way. Probably maybe I do not know how to. But there is a code saved in the memory. So what is the issue? The issue here is that in the interactive mode, user interactive mode, 257 and 257, they are using the same space. So it returns true. But if you have two different locations, then two different, they are not binding in user interactive mode. Okay. That compiled code can be another way that you can have this assembly code is by code disassemble. When you run a Python program or any other program, it converts it to the assembly code so that your machine itself can understand that assembly code. It is already in your bytecode. For example, like this, in your bytecode, it is already assembled in this way. Can we disassemble this so that we can see more clearly? That is done by this code disassembly. How? Here's the way. You can import this for disassemble, and then this has this function that includes the assembler code. What happens? Here we already had compiled code. This is a compiled code, right? Because this is we compiled. So code A is converted. There's a bytecode like this. This is compiled code in this way. B stands for bytecode, but we do not understand what it means, right? Can we see it by disassemble it? In order to do that, you have to import this, and then the code name, code underscore A. And returns that. Constant, loaded constant is 257. Name of the store name is A. So A, we know that, what it is, right? And load constant, another constant is none. And return value. Okay. So let's try that. Combine the code. A equals, for example, code underscore together equals, no, SRC2 equals, A equals 257, B equals 257. Okay, and then compile. Code together equals, source equals src2, comma, file name, there's no file name, and mode, execute. And then you can say this dot this code together. Load constant 0 from this 257, that constant loaded, and then store name A is loaded here, and then this 257 is loaded, but it's the same location, A. See here, I do not clearly in this is not really memory it doesn't give us a memory location. It's not like C. When it comes to C, then we know specific location, memory location, and that certain variable holds a certain value that clearly can see in assembly code. But this is a little tricky here. Only what I can guess here is that this value version 0, this value version 0. So which means that they are the same location.
Yeah, Professor, I was
What?
checking something different and it's true because I was trying to use in a search combination A equal 257 and B equal 256, so two different constants, and here it recognizes two different values. So 257
Hold
is
on.
recognized with 0
That's
and 256 is recognized with 1. So it's true, it recognizes this.
right, two different versions, right?
Yeah, it was
But
checking for value.
257, it refers 0, 0, this
Exactly.
points to the same location. Here, A and B, there are two different values. So this points to 0, this points to 1. They are two different. But the value, same value, 257. That's what it means. That's how Python. Is Python interpreter is implemented. Okay. Another trick. Python. Okay. You know, tick tack toe, tic tac toe. Tic tac toe is a simple game, right?
Yes.
I don't know.
You don't know tic tac toe? You will know tic tac toe. Tic tac toe is this. It's a very simple game. Only elementary school students plays that, right? They draw like this and. You wanna play? Julian, Olivia?
Yes.
I want to go in the middle.
Oh, yeah, go to middle. You will win, right?
Okay, okay. We have different names.
And then let's say Olivia put here and Jessica for
Bottom corner.
bottom
No,
corner.
yeah, right there.
And Jessica protected. Right? And after that? So we know is that if we have all this, then this is the winner, right? That's a tic-tac-toe. So let's assume that you want to implement that in Python, but not in GUI, graphical user interface, but using a list. So board is a list. The way that you can see it over there, I can say like this. I can simply create, let's say row equals using list, but nothing, times 3. Then if I say what is a row, then we have like this, top row, initially all empty, so that we have list all empty. Fine. So real tic-tac-toe board, you can say board equals row, you put that row in a list, and times 3, then board equals like this. So that is a tic-tac-toe data structure, right? Like this. For this list is a nested list. So if you look at this, then there's a first row, second row, and third row. So we have exactly that.
Can you zoom in on it with the magnifier? Just so I can see it back here.
It is already big, but I do not know why it is small here. 20. So I'm going to increase it 36. Font size is 36.
There we go.
Thank you.
Right? So now we can play. So somebody that is a two-dimensional.
Or isn't it supposed to be interactive?
Right now it is interactive, right?
No, like for input.
Right, that's what I'm trying to do. So let's say to give you this whole thing can be interpreted right? Jessica wants in the center. Then which one is the center here in this list?
1. Position 1. Isn't that 0, 1, 2?
This is the first row. This is the second row. This is the third row. That is what this structure means. And this is the first column in the first row. This is the second column in the first row. Then, according to Jessica's first move, which one is marked X?
In the middle?
Which middle?
The second,
That one.
second section, second position.
No,
This?
No.
no,
This?
yes.
Oh, great. This, right? You want to put this. How can you index this? This is index 0, right?
Zero.
Starts from 0, this is 1, and this is 2. And index here, so this is index 0 and 0, right? This is 0 and 1, 0 and 2. This,
1 and
1 and 0, 1 and 1, and 1 and 2, and 2 comma 0, 2 comma 1, and 2 comma 2. If you move first, then what it would, so the index is this. So she wants to first move to this, right? Which is nothing but here. So what should we do? 1 and 1, right?
No.
it's 2 and 1.
I did this and you recognize for each element in the one, it gives us.
That's what I'm trying to do.
Ah, okay.
Don't go further.
I was checking, but it's not the correct answer.
So we put X here, right? X. We'll say an X. Let's see board. What happened? There's another nonsense. She wants to move all here, right? She wants to or move here. Anyone has any clue from the nonsense that we looked at earlier?
It's trying to recognize that it's the same object, so it's duplicate.
Same place,
It's
right?
the same place, so it's a
So
tricky case.
Python is interpret the same array.
But don't you,
Huh? Same array that we looked at, for example, A equals 256.
but don't you also have to define a column and a row? In the,
Exactly. But what happens here is that when I have this, it has this. Say this is row 1. And row 2 is not creating new, but pointing to the same. Row 3, which is here, point to the same here. So when I do 1, it always come here and mark X. So when I
so it gives you tic-tac-toe automatically.
You win.
first move, you will win automatically. Exactly. Whoever comes first will win. That's a Python. So using once doesn't matter if we do. Let's say here, board 2 equals row times 3 again, and then I board 2, and I want to put 1 and 2. What it does is that it takes 1 and 2 and mark X here, therefore all marked. So it doesn't care about this. Anything wrong? That's what it means by that.
What do they want?
Memory structure is like that. So board 0, board 1, board 3. So if I say 1 and 2, then it refers here. So this may not be. This. Yeah, it's somehow. It's nonsense anyway. Okay. All right. So list has, so what is the problem of Python? If you do multiplication of the same structure, multiplication is big advantages in Python somehow. If you want to multiply it, it works very nicely. But as you do multiply, it uses the same data structure. So it doesn't manipulate the data properly. That is the point. Another issue. There's a function defined depend underscore cat, one argument, L equals list, and the body of that function is to append cat and return L. That's our number one, is L for list. Here, L equals list, and into the list we append this string cat and return L. And that is the function, and I invoked that function here. So what is the output? Those who, without programming, without scripting, what is conceptually, what would be the output?
It should be an array.
If I don't give anything here. If I don't give anything, then it gives the cat, right?
Can you do it? So it's one of the parameter inside the definition is L equal an array. Can you do this? So you create a parameter inside.
Well, yeah, that is possible. That's
Is
what.
possible?
Mhm, yeah,
Oh, good.
that is.
Yeah, I was just
Right, there's a
trying
Python.
to find this way.
Right.
Good.
That is the strength of one of the strengths in Python. So we use that Python. Her question was this parameter itself can itself is another statement. Java somehow we can do some of the not real like bring data structures like that. But anyway, if I don't do anything here, But in the code, it gives you by default, which means just listed. And then cat is appended, therefore it returns cat, one cat. So far, so good. But if I do more and more, that is the problem. Thing is this: define, append, cat, and then L equals this, and then colon. This is a function, so that we need to have indentation. L to that list, empty list L, I'm going to append a string cat, and then I'm going to return L. And let's try. Append cat, returns cat. That may be okay. But if I do,
It will recognize the same object, so it will be only one. If you recognize that is already inside the list, maybe it will not give you.
but surprisingly, two cats.
So,
One more, three cats. One more, four cats. One more, that. That. Why? There's another implementation nonsense. In order to know why that happens, in Python there is a tool, you may know clearly. If I do append cat and then defaults, right now at this point, what is the default? Before I execute that, current default is that. This is the default. And then if I do one more, this, to that default, to this default, add cat. Exactly the way that we initially, default is empty. Therefore, cat is appended to the list. But defaults keep changing. Right now, the default is one more cat. If you see default, it's one more cat. When I see here, defaults is how many cats? 1, 2, 3, 4, 5, 6 cats. Do one more time, and then when I see the defaults, then 1, 2, 3, 4, 5, 6, 7, one more cat. So defaults increases.
Professor, but this is only a problem for the interactive mode, because I did this.
Right,
with the Python.
interpreter.
Yeah,
issue.
because it's like it doesn't recognize to clear the list. So when you enter in the parameter, it's not clear in the list,
Mhm.
empty.
Right. Interpretation. Another. Python has a scoping nonsense. Okay. Scoping nonsense. You know scope. In typical programming, if you have a variable, let's say a equals 7, and you define function, and within that function, if you say here in this a equals 7, that is outside that function, and then you define the function def foo return a. What would happen? Typically, because A is not defined, A is not recognized, that is the error message usually in Java or C. What happens here?
If we use the global, we recognize this.
You already saw the answer. So, to find it, we can do as a equals to 7, and then define the function foo. We can say return a, and then when I say foo, return 7. Some of you, oh, that makes sense. Then it turns out that you lack the programming concept. Programming in real typed programming. This may be okay in Python. Which means A is defined outside this function. So inside this function, if it returns A, then this function should say, I do not know A, because that is beyond my territory. My territory is within this def, data, within that. I do not understand. In Java, unresolved symbol, A, but it returns 7. To understand that, if you do also, for example, this foo, there's a function.
It's 8.
This. Right. That foo, function foo itself understands A. And it refers to global. It allows global variables. That's what it means. Okay? So in order to do that, if you say globals, then
Throw a post over?
Oh. Global is globals. If you say global, then global is not the same as globals. Globals is a function. It gives you global variables. So if you see the global variables where there are, all of this is available. So but again, in real, the file, Python file, if you expect that, it's not going to work. In real file level programming, what should you do? I think we already have a file, right? So let's try that. Oh yeah, here. If I do A255, so let's define foo return A, and then print foo. Save this. Now here, it works.
How can it
Usually
be
it's not.
possible?
Usually it's not recognized. It's nonsense. Right? If I do here def good, another function, and I'm going to remove this. I'm going to remove from here everything. Okay, so I have two functions. Some of you might not. How can I? Format? Fonts? Okay. So 22. Then more clear, right? So I created two functions, grew and foo. What happens? I need to do this. Properties. 36. Okay, grew and foo. Run it. There's a problem, right? Outside the function, but it is a top level, then it treats as a global, right? In this way, it works. This is a local. This is a local. But if I have global here, let's say C equals 7, and then if I say C here, then it works. So globals now run it. Okay. So foo returns 7 because C is outside this function, but treats because this doesn't belong to any function but top level, so it is treated as a global variable. So if you see here, then see here, right? C is treated as a global. But there's no A and B, right? Similarly, if I do print locals, right? Then you can see local variables. They're the same, locals and locals. But see the difference? How can you see the difference? If we put this internal here, then you can see
You're not calling the function go.
locals are not printed. Global is only printed. Oh, because I didn't call. So I didn't. Need to call here. Foo 7, who come here. I didn't do anything, only print locals. There, that is written. After this, if I say print globals, and as we could see last time, right? 7 this is who, this is who, but I didn't do any. Return none. The globals. This is global, this is local. But if I interesting. If I put here local, see what happens. So I can say I want to print locals within each function. See the difference. Then save. Just save. What would be the outcome? I didn't run this yet. Outcome here. Print foo first, right? So go here. So local in foo should be printed first. And then print gu. Back here, local, capital, local in gu, that is printed. After that, globals, all globals. That is the logic. So do this. Local in foo, there is a no local, no local variable. But in this case, only global variables, all global variables are available in foo. Gu, A and B. Right?
Why did it print it backwards? B and then A.
That is in memory.
It does it for all of them, and I think it's for.
Hold on. There's a reason. I think we did this last week, right? Let me. Stack. Right, stack grows. There's a constant value. It depending on how it is interpreted. A equals 257, then it is treated as a constant. I'm not sure in Python, but in real programming, like C, constant is not the same as initialized value. Constant is a constant, which means it cannot be changed. Initialized value, in Python, A equals 257. We don't say that it can be changed or cannot be changed, but it is initialized in Python. But in real programming, we can differentiate, right? If it is constant, for example, in Java, then what should we do?
If you use static, it will be
Yeah, static is constant. And final variable equals 255, then that is a final value, which means constant. It's not the same as A equals 255, then that it can be changed. So a little bit tricky in Python. But anyway, code is scanned, right? So A equals B equals something. So A equals something and B equals something here, right? I write A equals 255. In that stack, this is a high memory. Let's say FFFF. This is OX 0000, low memory. Let's assume my stack starts from here. So A equals 255 and B equals 255. Stack grows in this way. When I print that, scan from low value, so B appears first, and A appears Therefore, B comes first. A little bit tricky, right? That code needs to be loaded in memory. This is memory.
But only if you want to print the global or the locals, because if you want to print an array, they give you the correct order. If you are an array, so each element should be append later. You give the print an array is correct. If you print the locals or the globals,
That's what we hear
they
in this.
spawn in the opposite
That's
order.
that's towards here. In the implementation, array for integers, that's towards here. But in real programming, program loaded, then that is loaded here. In program is scanned and loaded here. It loaded in this way. Read first line, A equals to 50, B equals to 2, and whatever that is. But when I print it, it prints from the, yeah.
So if
This
you
is a
add-
first. This is
so
a
if
first
you-
address. This is a last address.
So if you
It
add-
doesn't print you from the last address. It prints you from the first address. So it knows this is the frame of that program. What's the program ours? Whatever our program, xx.py. This is a frame.
So if it had C equals 255, B equals 2, it would start with, it would print C first, then B, then A.
Correct. Yeah. You'll see that in C code assembly later. I know it is a little bit tricky, and if you the first time to run it to know this, then a little bit inconvenient, but that is okay all the time. This is a little bit okay. Let's try now. Okay. Yeah, Stack Overflow. So this grows. Stack Overflow can be demonstrated if you have multiple iterations. For example, we can create the function deep and deep, which takes number, depth, and this is the body of that function. You don't have to worry about this. All equals braces, curly braces, which is what? Yeah, it is. And for loop here, for I in the range depth. So given that number, I want to iterate that many times, and then I create another dictionary and another dictionary. How many dictionaries? So initially, dictionary, and another here. And then I want to assign this dictionary into that. And then n, dictionary n is equal to all. So all is increased at that time, return. I want to do that 100 times and 200 times, and so on and so forth. What do we want to demonstrate here is how quickly that program consumes stack spaces. Therefore, you will have stack overflow. Stack is that for particular program, right? It runs that program and it consumes the space here. But in memory, you have operating systems and all possible, whatever the loaded, whatever clicked, then it loaded here. Something that you cannot access, for example, operating system, code itself. So it consumes up to somewhere here. We call that heap size, heap, H-E-A-P, heap size. That consumes this much. And for the application programs, it grows from the top. We call it stack. If program creates and therefore use memory more and more and more, then it consumes. This grows. And finally, there's no space, no memory space. There's a stack overflow. So let's demonstrate that. There are many ways that you could do, but we want to create like this list or dictionary. We keep adding and increase that dictionary. How many times? If I send the 100, then so 100 times all created and created. Okay. Can you do not only 100 but 1,000, 10,000, 100,000? In what way it is? It consumes all the memories. Right? So we will do that after 10-minute break or 15-minute break. It's time, right? Time to break. And meanwhile, if you want, you can try that. Global end time, that is, forget about that. I tried that by calculating elapsed time, but I didn't erase that. Elapsed time. Then you have to import time and start time, end time, and subtract them, then you will have elapsed